Welding is a technology on the one side. On the other side, manual welding is a tough job. We have this health and safety hazards. It's absolutely necessary that we have improvements here. What's going on in the R&D scene? How does this affect also the fume emissions? There will be no compromises regarding quality.
There are also new developments. That is also part of our research. Is there any influence on the weld quality?
That's still the biggest fear of the welders. In the industry, also a lot of things have been done.
We also have to know how high is the level of fume exposure.
You know, it's a 100-year-old technology. Why do you need any research? Hello, everybody, to the new episode of our Weld Lounge. And today I have the pleasure to have Dr. Rahul Sharma here. He's head of the arc welding department of the Institute for Welding and Joining of Aachen University. So welcome, Dr. Sharma.
Thank you for inviting me.
Today, our topic is health and safety in welding. And the focus today, as we have the research expert here, of course, should be what's new, what's upcoming here on the research side. We know that in industry, there are quite a lot of activities regarding health and safety and welding, and this is really needed. We all know we have that lack of welders. Welding is a technology on the one side. On the other side, manual welding is a tough job, and we have this health and safety hazards. So it's absolutely necessary that we have improvements here. And beside the activities in industry, we know that also a lot of activities are going on the research side. So when we, let's say, try to structure our talk a little bit, we said, okay, let's use that STOP principle. Yeah, I think it's well known, and the good thing is we can also use it internationally. So STOP stands for, on the one hand, substitution, the S, the T is for technology, the O is for organizational aspects, and the P, finally, is then for personal protection equipment. Yeah, let's start with substitution. Of course, what we do not want to do is, switch from welding to adhesive bonding. That's not what we mean as welders for substitution. So what's going on in the R&D scene on that aspect?
Yeah, substitution itself can mean that you switch to another welding process also, but in fact it is also possible to better make use of the possibility when, for example, gas metal arc welding is used. It is also possible today to switch to a more advanced welding process variant. For example, the pulsed gas metal arc welding process. Or there are also possibilities to use modern regulation variants, controlled short arc processes, for example. And these process variants include, in many cases, reduced emission of welding fumes. But this knowledge, how they have to be controlled, there is some knowledge there, but there is further research needed so that, for example, the manufacturers of welding power sources, but also the users, the welders, know how to select the right process variant, and that is part of our work.
Okay, because in the past a lot of these developments were of course focused on, let's say, higher quality of the welds, higher productivity, but it's changing now also towards, okay, how does this affect also the fume emissions?
Yes, right? At the same time, the quality is still the main goal. When we talk about welding, quality is a must. But in many cases, this can be combined with reduced emissions.
Yeah, there will be no compromises regarding quality. That's for sure, and that's always a fear of let's say, the welders or the welding companies. And of course, that has to be avoided. So the main, let's say, part of the emissions really come from the filler metals. And we mainly talk about MIG-MAG welding, of course. Are there any possibilities or activities going on how to reduce emissions on that side? What can we do with the wires, maybe with the shielding gases?
Yeah, we know nowadays that the metal vapor, which is produced mainly out of the filler wire, which is melted in the arc, leads to welding fume emissions. And the activities in research are, for example, to reduce this metal vapor. On the one hand, this can be done by using specific shielding gases, which are on the market, but in some cases not used. But there are also new developments. It is, on the other hand, possible to develop new filler metals, and this is currently done in the industry, for example, to reduce the manganese content. But it is still necessary that we know how the mechanical properties of the welds are. So this has to be investigated, how these filler metals behave.
And in addition, what makes it even more complicated, if you change the welding gas, the shielding gas, if you change the wire, it means you also have to change your process parameters.
Yes, that's it. Yeah.
So what's needed is really the cooperation here between, let's say, welding power source manufacturers, wire manufacturers, the gas companies, and the research institutes, which is running. Yeah. So let's say coming from this substitution efforts to the next topic, that's the technological possibilities that we have here. It's still, I think, mainly, and that's also what's recommended also from the authorities, that we should have extraction at source, how it's described. So what does it mean, you know?
Extraction at source means that the fume resulting out of the welding process is immediately extracted, for example, by a fume extraction welding torch, which are on the market since long and have nowadays a very high level of usability and also of efficiency regarding the fume extraction. And that is also part of our research to investigate how the quality is there any influence on the weld quality, because this is most important. I can say our last research project regarding this topic showed that the available welding torches on the market now in typical welding situations do not lead to reduced welding quality, for example, porosity in the welds.
Because that's still what I hear the biggest fear of the welders, but also, of course, of the responsible welding engineers. Yeah, I may, also extract some of my shielding gas, and then I have all these quality problems, porosity. So that's a done deal. So nowadays you would say that's state of the art, no quality problems using fume extraction torches.
Yeah, the combination of the fume extraction torch together with the fume extraction device, the ventilation device, this is a very important topic, but it is quite easy nowadays to set the parameters in a way that no quality issue will arise.
Okay, I think that's good news for the welding companies. I know on the other side in the industry also a lot of things have been done to reduce the weight of these torches and also to improve the accessibility, because these were the other 2 points where a lot of welders said, okay, it's too heavy, torches are too clumsy, I cannot see where I'm welding. I think that's also resolved. There are many different offerings on the market, and now if, let's say, we know that the quality will not be affected negatively, we are on a good path here.
Yes.
Okay. No, that's good news also from the technology side. So let's go to the next aspect in our STOP principle, the O, that stands for organizational measures. Of course, one thing is, especially if you are, let's say, like a small and medium company, that the welder, of course, he has to do preparation work, he has to work after the welding. So to, let's say, keep the arc on time a little bit lower, of course, would help to reduce, let's say, the load of the welders with welding fumes. But for the companies, that's, of course, not so interesting because the productive step is the welding. So which other organizational means do we have?
Yeah, the classical way of organize the work of the welders in a different way would be to use a higher level of automation of the welding processes. But I have to say this is not possible in any case. There are ways to increase the automation level partly, but there will be still tasks where manual preparation is needed. During the last years, intermediate possibility arose, and that is the use of collaborative robots in welding. And this is also a current research topic which is still going on, because the cobot, in combination with welding tasks, which are typically carried out manually, can also lead to a reduced exposure to the welding fume, because the welder now stands during arc on time a step back. That is one important possibility. But there is still further research going on that side, because we also have to know how high is the level of fume exposure, and therefore we need sensor data. One possibility we have is the use of fine dust sensors, which are already available on the market. These fine dust sensors can be used to measure the level of fume exposure, not only welding fume, but usually the highest amount in welding workshops of fine dust is resulting out of welding fume. If we measure this welding fume, then we can also give companies the possibility to decide, is there a need of a different work organization or not?
Absolutely. You need a starting point. Yeah? And if you don't have any data, what should you do to improve? You don't know where you are. So this sensor data, it's very important. I think many companies think, okay, but that must be incredibly complicated. It's very expensive to have these sensors. So how can we look at this? Is that still the case, or are we moving in a direction that's affordable?
Yeah, the use of fine dust sensors specifically is, from my point of view, not a matter of cost, because these devices are nowadays widely available. And also at our institute, we have a research topic where we try to use very simple Internet of Things sensor devices, which have a very low cost level. And this can be integrated on a high number of sensors into a network, and the cost which will result will not be the sensor technology, but will be more on the integration side in the whole workflow in the company.
But still, if I imagine, and I think that's also good news, if you have a welding company that has, let's say, maybe 10, 20 welding workplaces, you equip them with sensors. I even saw cobot welding cells at exhibitions that are already equipped with these fume sensors. And then the responsible persons for health and safety in that company, they can now watch from their office, from, let's say, like a control panel, okay, I'm always on the safe side for my welders. And I think that's also worth some money. And yes. That's a good development that now we have this IoT, industrial Internet of Things technology available also on the fume sensor side. So we can overall improve the safety and health level in the welding companies.
Yes, that's it.
Very good. So some exciting news also here. R&D is still active, because in many cases when I talk to people who are not from the welding field in the detail, but let's say just look at it from the outside, I hear, it's a 100-year-old technology. Why do you need any research? And I think we just learned there's so many things going on here still, even if it's arc welding. So coming to our last point, which is the P, which stands for personal protection equipment. Of course, that's important, but it's not by chance that it's the last step. So it's really also an order here. So you should really start with substitution, followed by technological aspects, followed by organizational measures, and then the very last step is personal protection equipment.
Yes.
Some companies tend to turn that around, but that's not the right way, because you should use all other possibilities before you start this. And maybe, of course, sometimes it's still required to have personal protection equipment. So, I think what comes becomes more and more popular are these welding helmets with air ventilation or respiratory devices. Is there anything else going on in the R&D scene in that area?
Yeah, regarding the respiratory devices, mainly the focus was in the past to increase the ergonomy of the devices, the weight, or also the comfort, the wear comfort. But there's still work going on regarding the integration of data on the one side. This is not limited to the respiratory devices, but generally to protection helmets for welders, but also the link to, for example, to the fume extraction devices or the welding power sources. This is also a topic where further development is done and is needed.
Yeah, so that's
the
like
connectivity.
The look in the future. So still fields where there is additional research needed.
I would think that one important point is the possibility to show welders the current level of fume emission of the processes, because it is always difficult to know how the personal exposure is from emission of fume, but it can be a hint to, for example, change the welding parameters or look after a better fume extraction level.
Yeah, and of course, he would be alerted that I'm now on a critical path, and maybe I have to even take a break and see, put my ventilation system up and wait until the pollution in my working area is getting down again, to be on the safe side. So that's I think that's also good news. Yeah, but I would say observing activities both in industry but also on the R&D side, I think we are on a good way. I think all the players have let's say, seen and accepted their responsibility to do something, because we need welders, and if we don't find welders, we have a problem in our industry sectors. So that's one thing. On the other thing, I think also the companies carrying out welding, of course, also have their responsibility, because they are responsible for their employees, for their welders especially. But as a industry sector, I think what we have to do is to improve our, let's say, information. That's something we still have to do, and there is room for improvement, I would say. All these new things, all this news really have to reach the end users. It's nice that you know it, what's going on, that I'm knowing it. We are, let's say, as specialists, but it has to come down really to the level of the end users, where welding is applied in an industrial surrounding.
You are totally right.
I think that was exciting. Also learning what's going on the R&D side on our old arc welding technology. So thanks a lot, Dr. Sharma. Was my pleasure talking to you.
Thank you. That's on my side.